So any included side or angle is just between two other sides or angles. Questions on included sides or angles? Okay, what do you notice about the letters? If angle C is included between AC and CB. Mariana?
No, I'm looking.
Oh. Does anyone notice anything about the letters? Gabby?
The law. Is that the something?
You're on the right track.
What? The law of syllogism?
Well, no, we're not. Look at AC and CB. What's the same about them? C. So that's your included angle.
Oh, okay.
Okay.
If it repeats.
If it repeats, okay? Take a look at AB, right? The segment. It's included between the two angles that form that side. Do you guys see that?
Yeah.
See, we didn't use C at all.
Yeah.
And A and B were used once, so we didn't use those at all for the angle.
Yes.
Okay? All right.
Gotcha.
Okay, now, what side angle side theorem says is it says you don't need to prove that all the angles and all the sides of a triangle are congruent. If two sides and the included angle of one triangle are congruent to two sides and the included angle of another triangle, then the triangles are congruent. And I want you guys to draw a little picture for me down here. Okay? Draw a little triangle and draw as close to the same triangle as you can, or just completely copy and paste it. And I want you to draw a congruent segment here, here, and then a double one here and here, and put an angle that's included between them. So as long as you have two sides and their included angle that are congruent, you've got side angle side, and you can say that these two triangles are congruent. Okay?
Aren't they literally the same thing?
What do you mean? Yes. So I'm going to show you an example though where it won't work. I can zoom out, yep. Why? Oh, there we go. Now, read the orange letters. Order matters, okay? I'm going to show you an example where two sides and an angle are congruent, and you have to tell me why we cannot apply the side angle side theorem. Kaden. Okay? So, take a look at the triangles down here. Draw two other triangles. 1, 2. But put this angle and this angle are congruent. Someone tell me, based on the definition that we just learned about side angle side, why are these two triangles not congruent? Savannah?
Because the angles are not the same like on each one. So, for example, that's like angle A, on the other one's angle B.
Correct.
It's not the same.
Very good. Do you see how this angle is not an included angle? It doesn't lie in between the two congruent sides, right? So we would say that these are not congruent. Okay?
Can you please send Julia Malou to Student Services?
Yes,
Like, obviously they're not going to be congruent if they're not exactly the same.
correct. Now, other examples that we're going to look at, there's going to be information that's missing though, okay? So it won't give you any angle, and you'll be like, we can't apply side angle side because we don't know enough information, okay? All right, let's start doing some examples. That is all we're learning, okay? State which congruence method you can use to prove that the triangles are congruent. If there's none, state NC, okay? Let's look at A. We've got one set of congruent sides. Do you agree?
Yeah.
And one set of congruent angles. There's another side of each of these triangles that's congruent. Does anyone notice it? Emma?
The line that goes down the middle.
Very good. Do you see how the line down that goes down the middle is congruent to itself? It's being used for both triangles, right? Can we apply side angle side here? Talia shaking her head no. Why not?
Well, I also
Okay. Go ahead. Answer it.
Because it's like, no, I don't know. Because I saw it. I already know the answer.
Mariana?
Because for it to be congruent, the angle would have to been on this side because it has to be exactly the same.
Correct. This is side, side, angle. Side, side, angle. Has to be inside. So we're going to put NC. Okay? Because, do you see how it's not SAS? It's SSA?
Yeah.
Don't say the other way, okay? It's SSA, okay? It's not SAS. Do you guys see that? Okay. Now let's look at B.
NC is not congruent.
Yeah, just put NC for not congruent, okay? What about B? Xavier?
Yeah.
Yes. Now, why would these two be congruent? There's two pieces of information that we need to gather. Savannah?
Because the angles are on the same side.
Okay.
And the lines, the little congruent lines,
Yep.
are also on the same side because in the middle it's congruent to itself.
There we go. This one is congruent to itself. And we've got a side, an angle, and a side, and a side, an angle, and a side over here.
So it doesn't matter if there's only one more.
Is there another angle that's congruent?
The right angle.
The right angle. Why does this side have to be 90 as well? Giselle? Excelente. They are a linear pair and 90 plus 90 has to equal 180. Cool beans? Okay. These were pretty easy. Check out C.
Oh.
Isn't it the one in the middle? Nope. No. Wait. What do we write that?
Giselle? Oh, yeah, you would write SAS, sorry. SAS. Side angle side.
No, it's not because
Hold on. Giselle, what's your answer for C?
not congruent because if you flip the triangles that the butt end is facing the butt end that I don't know the one with the line. I don't know the butt end, man. I don't know the line one.
Okay.
If the line side is on the right one is facing the opposite way, then it's opposite angles that are like. What? Oh
But-
wait, no, because one has two lines.
Ah, these aren't even congruent. Do you guys see that?
Yeah, I see that. Okay, so yes.
So we only have a side that's congruent, but we do have a set of congruent angles. Which two angles are congruent? Isa? What's that? No. Which two angles are congruent?
On the side.
Which two angles are congruent? Javier? The vertical ones. So this one is congruent to this one.
Wait. Oh, true?
Why?
Because
They're
there.
very good. They're vertical angles. Why did I have to put 3 marks here, though? Yep.
Because one has that one, which means anything that has two would be that angle, and anyone that has one that one, but they're two completely different.
Very good. Very good. Okay? If we used one congruence mark, it would say that this angle is the same as this one. If we used 2, it would say that this angle is the same as these two. So we had to use 3 marks to say that this is a different angle. Yes?
So if this was like on the test, we could just say, we would obviously write that down and say NC.
Yes. Okay? But this kind of question, something this easy won't be on your test.
So you
Okay?
can put NC.
Yes. Just put NC.
Something that's easy. won't be on
What about D? Emma?
Yes, because the line down the middle is congruent to itself. So it's
Excellent. So it's sassy, baby. Okay? SAS. What do you mean?
They have one line.
As long as it's just one. Just so, because if we drew them like at the same spot, it would look like that, and that looks weird. That kind of looks like it's just one congruence mark for both of them. So we had to draw them separately.
Answers are gonna be NC or SAS.
Correct. Now, we're going to learn more theorems, right?
There's like.
Oh, I'm sorry. Yes, this was SAS. Thank you.
Isn't there angle side?
Yep.
And then
No, that's the one that's not.
no. Oh yeah. 'Cause my tutor said that, and she's like, oh wait, no, it's not.
And it's so weird looking. I don't
Oh.
know what is going on here.
Okay.
I know.
Can we do SAS here?
No, because there's no side.
There's no sides, so NC. We don't know that any of the sides are congruent. Do you guys see that? If the angles are, but couldn't it just be a bigger version of the other one?
But wouldn't that mean that the angles are
Which do they always have to be touching? Is that
like logically, like
No.
if it's bigger.
I don't get it.
So even if, like, you could say that, like, this is the same shape technically as the board. The angles will all be the same, but this side clearly is not the same length as that side. Okay, so this one's not congruent because there's no congruent sides. Example 2. Is there enough? There's an E. Okay. All right, example 2. Is there enough information to prove that the triangles are congruent? If there is, state the postulate or theorem. Obviously, we only know one, so we would have to use SAS, okay? But let's try to prove that side angle side applies to these two shapes. Let's highlight the two shapes. ABE is this triangle right here. And then CBD is this triangle right here. Okay? Now, let's go ahead and let's write down the two sides that are congruent. Do you guys notice a pair of congruent sides here?
Okay, hold on.
Savannah?
AB and BC.
AB is congruent to BC. So this was a pair of sides. What else do we see? Xavier? BD and BE.
And one more.
That's another side. Now, we have to prove that their interior angles are congruent. That their their included angle is congruent. What angle in the black triangle is the included angle? Savannah?
B.
It's not angle B, because angle B could be a bunch of different things. What? Nope.
Wait.
Okay, it is at point B, but it is not called angle B. Xavier? AB. Nope. AB. No, it's not ABC.
ABE.
It's ABE. Because it's this angle right here of the black triangle. Okay? So angle ABE needs to be congruent to DBC.
So just because that's the angle that like interlocks.
Hold on. Needs to be congruent to angle DBC. This is our angle. Now hold on. This one, we are not given that those two are congruent. Do you guys agree? It's not given to us. We do know that ABD is congruent to CBE. Do you guys see that? Based on the congruence mark. So write down angle ABD is congruent to angle CBE. Now, this angle DBE is included in both of them. Do you guys see that? Okay, now watch. We're going to break down each of those angles. So let's start with the congruence statement. ABE is congruent to angle DBC. I'm just grabbing this and pulling it down here. Okay? Let's break up ABE into two angles, okay? Into two angles. So look at ABE. What two angles make up ABE? Giselle? Those are two lines, two segments. What two angles make up ABE? Gabby? Yeah, Kaylin?
Wait, angle ABE?
ABE, yep.
Isn't it ABE and DB?
Excellent. ABD and DBE, okay? Hold on, guys. Hold on.
Oh, I got it.
So angle ABD plus angle DBE. Okay, so this needs to be equal to, let's break down CBD. What two angles make up CBD? Emma?
DBEEBC.
Excellent.
Oh, I get that. Okay.
Okay, it's DBE and EBC. Okay, angle DB
No, equal.
equals, because we're talking about their measures now. Actually, we should put M's before these. We're talking about the measures now, so this should be equals, not congruence. So DBE plus, what was it, EBC? Now, do you guys notice anything in this congruence statement?
No. What? Yeah.
Kaylin?
Yeah. Oh, DB. It's repeated.
Very good.
Included one.
So angle DBE is repeated, right? So what would happen if we subtracted DBE from both sides?
Measure of angle ABC. But what does this have to do with that?
It's like math with letters. What is it?
So if we took it away from both sides, you see how it would go away? We would get the measure of angle ABD is equal to the measure of angle EBC.
I know. I just don't know where we're going. Jane's gonna be lost.
It would need to be SAS, not S or
Would it tell you that you
SSA.
need to use that theorem to
Yes.
find it?
Gabby?
But how do we know that they're like the same? Because they're not the same.
Yeah, but because it just says we need to state a third. We're also given that BC is parallel to AD, okay? How do we know that BCA, follow the letters, that's this angle. How do we know that that angle is congruent to DAC? Dylan?
I do know.
Would it be like alternate interior?
Excellent. They are alternate interior angles.
I was just gonna see.
It's the alternate interior angles theorem. Now, if we were to say that AC is congruent to CA,
Yeah, because they're touching and they're like the same line.
they're the same line, but what
Isn't that
theorem, what property are we
I
using
know.
here?
It's either the three symmetrical trend.
It's symmetrical. Very good. It's the symmetric.
Wait, why wouldn't it be
I saw the
reflexive?
video.
No, I didn't get
So reflexive would be AC is congruent to AC. Do you see how they flip the order of the letters? This is the symmetric property
Oh.
of congruence or equality, guys? Congruence. Yeah, you could put POC. And then how do we say that the triangles are congruent? What theorem do we use for the last step? What's the name of this lesson? SAS theorem. Okay?
I don't get why.
You don't get why? Okay.
Because look, it's the two lines are congruent, and then the others are congruent. Yeah.
Okay? So look, do we have a side, an included angle, and a side that are congruent? Side, angle, side. So the triangles are congruent by side, angle, side. Yeah.
When you have a triangle like that, the middle line is always going to be like
Yes. Okay. A shared side, that was a good question from Mariana. A shared side will always be congruent between the two triangles. Okay. Now, do you see how I just put one congruence mark?
Yeah.
That's to help you guys visualize it. Because it should be two sides that include an angle, and that angle needs to be congruent to the two sides on the other angle,
So
on the other triangle. Yes.
for
Ball shown in the picture. You think you can use two identical triangular sheets of canvas. You know that RP is perpendicular to QS, and QP, or PQ, is congruent to PS. Use the side angle side congruence theorem to show that triangle PQR is congruent to PSR. Savannah, what do you think we should do for this problem?
So we start off with QP is congruent to S, obviously.
Okay, QP is congruent to PS. And was that a side or an angle?
That was a side.
So put an S next to it, okay?
And then you see that RP is congruent to itself. They do RP is congruent to RP. And it's just one line.
Excellent.
And then you find angle, which is P, and you use linear pairs. So you see that P is congruent to P because 90 plus 90 equals 180.
So now comes the tricky part. What do we label? Okay, so let me just walk through what Savannah said, okay? So we're given that these two are congruent. Are we all good there?
Yeah.
Do we understand that RP is a shared side so we can say that it's congruent to itself? What property is this, guys? Did we apply here? This is the reflexive. Property of congruence, okay? And now our hardest part is figuring out what two angles would be congruent. We're given that they're perpendicular, right? So this 90 means the other side has to be 90, but why?
Because of the linear pairs.
They're linear pairs, okay? So I want you to draw a little arrow, put linear pairs. Now, this is something that we all struggle with, including Mr. Yurko. We need to be very good at labeling angles with 3 letters, because if we label it angle P, that means nothing, because there's at least 3 angles at angle P, okay? So we have to use 3 letters to identify both angles. So angle what is going to be congruent to angle what? Mariana, you want to give it a try?
QRP is equal to PRS.
Okay, so QRP would be this angle, and PRS would be this angle. We don't know that those two are congruent. Someone else want to try? Giselle?
QPR is equal to RPS.
Excellent. QPR is congruent to RPS?
Yeah.
Perfect. That's our last angle. Okay? Now, follow from Q, go to P, and then go up to R. What angle did we just make? The one on the left side. Do you guys see that? Then start at R, go to P, and then go to S. Do you see how that makes the two angles that are congruent?
Yeah.
So Giselle's order was super important, okay? When we're using 3 letters. Yep. Okay? Now, what letter, sorry, that's supposed to be a P, guys. What letter was in the middle for both of them?
P.
Okay? So that indicates that both the angles happen at point P. But we cannot label those angles angles P. Okay? So we can apply the side angle side theorem. SAS.